okay, this is the D, I thought. Well, no, it's 8D, the whole thing.
No.
No, it's just the D.
Yes.
Okay.
And the reason is, otherwise, watch this. Otherwise, if I have, so I'll get this kind of thing all the time. I get somebody tell 2x squared, they'll actually tell me that's the same thing as 4x. So see how the 2 just kind of jumped? But if the 2 is on both the x and the 2, then, so that's 4x squared, which is 16x squared. Well, holy shit, when do you stop? So the powers can only go so far. They're only affecting the thing that they're actually on. So if I wanted this 2 to be there also, I'd have to do this.
Right, the whole thing squared. Okay.
So when I see 8d cubed, that is an 8 times 3d's. Right?
So it is a cube. It is a cube then still, but just
Totally, because 8 can be broken down into 2, 2, 2.
And then
you know, D, D, D for the 3Ds, right?
So you need a 2D, 2D, 2D.
2D, 2D.
Not the 8D, 8D, 8D.
No, exactly. Because 8 times 8 times 8 is not 8. Yeah. Yeah.
Sorry, actually, I had a question about what you just took.
Sure.
Okay, it was like the undefined problems. I guess I wasn't sure.
What makes a fraction undefined? If the bottom is 0. So when I ask you what values of x make it undefined, what values of x make the bottom 0 is really how to translate that question, right? So if I said what makes this undefined, there you go. And if I give you one that's x squared plus then you got to factor it, and then you can see what makes each piece undefined. Yeah.
So then the answer would be like this or this kind of thing.
Yeah.
Here's
That's
my
fine.
quiz.
Oh, the correction. Okay. Thank you. All right. So hopefully everybody just turned in your corrections. You're turning it in early, so hopefully you're confident that you got them right. Yes.
Do you care if you write or is it we just?
Oh, and yeah, I don't care. Yeah.
I've had teachers that are really,
Huh?
who are really strict about like how things are written out.
Well, I mean, grammatically, you can say it either way. Mathematically, when you say and, like if I said the answer was x equals 1 and x equals 2, then how could it be 1 and 2? It can't be both. So that's technically you shouldn't say or. Because in math, and means you have to be both.
Yeah, I was just trying to ask if I just put x equals 1 and x equals 2 and nothing. Just that.
That's fine. Yeah, you're fine. Okay. All right. So anything else? What was the stuff from 76 before we get into the word problems?
It was the last problem with it. I turned it in right. It was like a...
Was it a word problem? All right. Anything else from 7.6 that's not a word problem?
Like questions?
Yes. Because I had to skip those from before the quiz.
I had a few.
Okay?
You want me to tell you?
No.
Okay.
Yeah. No,
No, because I didn't know if you were going to do the word problem first.
No. Questions first and then word problems. What's up?
Okay, so I thought I had 49 down, and then something just went funky.
All right, so 40, 49.
Yeah. Weird.
So 7.6?
Yeah.
7.6, yeah. All right, become 5. All right. This kind of thing always trips people up, but it's, I really want you to realize it's the easiest kind of thing to figure out in the LCD. Because what's the LCD of 1/7 and 1/8? I barely have to think. They don't have anything in common, so it's 7 times 8. It's only when they have something 12 and 8, oh shit, they have something in common, I got to think when they're going to meet. It's not 8 times 12, that's not the LCD. That's not the lowest. You with me? 8 times 12 is ACD. A common denominator, but it's not the LCD. All right. But here, this is easy. This is like 7 and 8. All right, 7 and 8. What's he missing that he's got? 1. Now look at all 3 fractions, though. So what's he missing that the other 2 have? He's missing a y and a 5.
You go 5, 1.
Yeah, so each of these guys needs a 5, right? And this guy also needs a y. Yes, sir?
I took a different route. Remember I said like 2 terms equals 1
Sure,
term?
totally.
Yeah,
You
so
can do
I
that.
just made it into 1 term, and then I just cross multiply.
Cross multiply, cool. So you could combine these, not take the 5 into account, just combine these, and then you'll have 1 fraction equals 1 fraction.
So you did 5 plus What'd you do, 5 plus y times y?
No. So what he did was, he just gave this guy a y minus 1, combined these to one fraction, because then you can cross multiply. That would be fine. The reason I don't show that in general is because it's not always the best way to go. Sometimes cross multiplication is, like I said the other day, it's too much. So if you do all three at once, it's making sure that you don't do too much. So what's this guy need?
Y minus 1 and a 5.
He needs a 5. Nobody's got a negative 1. Not a single thing up there has a negative 1. What else does he need? What's this guy have that he doesn't have?
Y minus 1.
A y minus 1. And that's the biggest mistake right there is I'll get this and somebody will say, let me just focus on this. How do I make these the same? And they'll just go, well, you do this. And of course, why can't you do that? You can't.
That would just turn the y into a negative, right?
Well, yeah, you have to multiply. You can't just subtract, but they are subtracting. Then these would be the same, wouldn't they? But you're not allowed to subtract a number from the top and bottom fraction. You're not allowed to do that. Or else 1/2 equals 0. You won $500,000, which is 0. Bye. No, that's not fair. Give me my $500,000. You guys,
Yeah.
you see what I'm saying? So you got to think about, what do I multiply by to make them all the same? So what's he need?
It's a y and y minus 1.
Cool. And now, of course, since they all have the same LCD or the same denominator, I can do what?
Cross out the bottom.
Cross them out because it's an equation. Don't get overly optimistic about I can kill every fraction I see in the universe. No. This is part of an equation, so I'm allowed to multiply both sides by this. So it cancels. And all the tops are just sitting there. Alright. So I'll let you guys finish that out.
No, but that's what I did, and I'm not getting the answer.
So let's see, what do you get here?
That's why I said I thought I got it.
20y.
Plus 5y minus 5 equals 6y squared minus 6.
Y.
6y.
Alright, how are we doing so far? Is that the same?
Yeah.
Minus
No, I
6y.
had to erase it because just like once you start trying to get down to the answer, it's like something in here's wrong. It has to be.
Okay.
How'd you get to 6y at the end? Isn't it 5y?
6y times y, 6y squared, 6y times 1 is 6y.
Okay, got it.
Yeah.
And I did that thing where you like subtract it so it's all equal to 0.
Sure.
I mean, I just erased it all right now.
So here you go. 25y minus 5. Subtract 25y, add 5. Subtract 25y, add 5 to make this 0, right? Let me stop there for a second. Why did I move things that way?
That's a negative.
Yeah, I want my first term to be positive. It makes factoring easier. Math doesn't care which side the 0 is on. It's just 0 is that, so that is 0. Who cares which way you write it? And now I do what with this? Why did I make it equal to 0?
Because there's an exponent.
There's a squared, right? It's a different power on one of my variables, so I have to. Right? So I got to get it equal to 0, and then I factor this. And how do you factor this?
Do the
Good. 6 times 5 is 30. Factors of 30 that make 31 is the easiest way to factor 30. 30 and 1. That's the one people forget about. Whenever the middle guy is 1 different than what you're looking at, it's going to be 1 in that thing. That happened on the, I think it did. Did I make it happen on the quiz? Yes, I did. Everybody had one like that on the quiz. Sorry. So that would be 30 and 1. I mean, that's as far as I'm going to go. I mean, you should get there fine. Now, cool. So you break the middle term up, group it, so forth.
But it would be a negative 30 and a negative 1, though, right?
Yeah, exactly. Yeah.
Okay.
I like it.
Okay.
So since there's a 0, can it not equal 30?
No. There's no, y can't be what? Because they're on the bottom at the beginning.
Oh, y can't be.
There's nothing here that's on the bottom of anything. So, but y can't be 0, y can't be 1. So if I get one of these answers, I have to cross it out.
Okay, gotcha.
But where I am now is I'm just saying what y's make this 0. Nothing undefined about that, just what makes it 0, that's all. So if this was like, if this represented my height above the ground, I want to know when do I hit the ground, right? Because 0 would be ground level. Does that make sense? I mean, mathematically, I can represent, it would be a down parabola, right? If I threw a ball, it would look like that. We know it looks like that. Even if you don't play baseball, whatever, you know a ball, you throw a ball and it goes, whee, right? So I can represent that as a parabola, and if I set it equal to 0, I can figure out when will that ball hit the ground, right? Which is how you do trajectories of missiles and shit. Let's throw a missile at them, and let's calculate it so that this equation hits this equation so it intercepts that missile. You guys kind of with me? That's a perfect example of setting one equation equal to another one. And why would we do that? So that we can continue to live, maybe. So math, all it does is keep you living. So that's nice. Thank you, math. Okay. Is there anything else before we do the word problems?
I had a question on well, I'm choosing between two. I'll go with 60.
60?
Well, I got 0 equals 2, so would that make it undefined, or did I get that right? Because that's the only part
60 should come out with an answer.
It should?
Yep.
Okay, then yeah. I have a problem with that one.
All right. So I just, let's see, just make sure you started it off correctly. So 60 and 7 6 says 4 over x plus 1 minus 4 over 2x plus 2. Is that right?
Is this the same section?
Yeah. So you notice something here by chance? Anybody notice something interesting about one of these three terms?
The x plus 1 squared is the same as that.
Okay, true.
When you do that,
There are 2x plus 2, you can factor out
Yeah,
the 2.
I can kill this too. So LCD-wise, I would have to take that 2 into account, but I can just kill it right now, so I don't have to. If you don't notice that, you're going to multiply this by 2 and another x plus 1. I don't know if you guys... Because when you factor this, what do you get?
x plus 1.
So this would need a 2 and that would need a 2, but do they really need a 2? No, because I can kill the 2. Nah. So whenever you see that, whenever one of your fractions reduces, yeah, do that.
You could do that in an equal equation? I guess that already actually.
I want you to realize, if I see 6 over 8 sitting inside of anything, that is 3/4. I don't care what, if it's 7 minus 6 divided by 8 times the square root of pi divided by the tangent of, you don't even know what the hell tangent is, 78 degrees. This is 3/4. So did I actually just do something? Did I do something to this side? No, I didn't do a damn thing to that side, because 4 divided by 2 is 2. I just simplified part of it, that's all.
Okay.
Yeah.
When you have all those x plus 1s that you have, 1, 2, 3, 4 of them on there, it's still going to be just 1 is the same across the board, is that right?
So what's he missing that he's got?
An extra x plus 1.
There you go.
Okay, so it's the
So he just needs another x plus 1.
Okay. That's where I got the...
What's he missing? He's got
Another one,
another x plus 1.
and then nothing.
And then he's got both x plus 1s already.
Okay.
Yeah. So that's the correct, or one way. If you left a 2 in there, if you didn't do this cancellation, then there would have been a 2 here. This would have needed a 2 on the top and bottom. This would have needed a 2 on the top and bottom. You would still get to the right answer, so who cares if you missed this. But, just kind of look for that.
So it'd be 4x.
All right.
Wait, that's a subtraction. So then would that be like a -2 distributing it to the x and the 1?
Totally. You got a minus sign. You can write it as plus and negative so you don't forget. Yeah.
Are you only taking a 2 out of the plus 2 right now? Are you taking out the whole column?
Right here?
Yeah.
So I factored the bottom, and then the 2 would cancel with that 4. Yeah. Because I can't kill either one of these 2's. I have to factor it so I can see what cancels. All right, maybe. All right. You guys look weary. I can relate. Okay. So let's get into the word problem stuff. There's one weird kind of word problem. Let me talk about it real quick. It's called a work problem. And this is the one that says like, I can mow a lawn in 2 hours. And you can mow the same lawn in 3 hours. All right, because my lawn mowing skills are awesome. All right.
This is 102?
No, this is a problem like what you might see in 7.6. This is called a work problem. So you see how it's the same thing as 102. One pump can empty the pool in 5 days, another pump. So one thing can do this in this much time, another thing can do it in this much time. How long would it take working together? Now obviously, you wouldn't say if we worked together, it wouldn't take us 5 hours. It doesn't make any damn sense to add these, right? How would it take us longer? Because we stopped. Hey man, did you see it? No, actual work time, right? Not how much time we sit there talking. You kind of with me? So there's no way in hell that together we would be 5 hours. In fact, could the answer be 2.5? Could the answer be 2.5 hours?
No.
No.
Think about it. If alone I do it in 2 hours, if I have help, we should be able to get it done in less than. So the answer has to be less than either of these. Does that make sense?
Yeah.
If you have help, you should be able to do it faster than you did alone. All right, maybe. Okay, does that make sense? So now here's how it works. I can do one lawn in 2 hours.
Cross multiply.
You could do one lawn in 3 hours. Together we can do one lawn in I don't know how many hours. No, so not. You can't make that
Oh wait, never mind.
1/5 or something. Yes.
Is it basically what you're just doing is you're just,
That's the same problem as that, just actually easier, right? What's the LCD going to be? What's the LCD of the numbers? 6, and you need a X. So what's this guy need? 3X. A 2X. And this guy needs a 6. Now they're all going to have 6X on the bottom, right? So this guy was missing this 3. It was also actually missing it was missing a 3 and an X, so I gave it a 3X. This guy was missing a 2 and an X, so I gave it a 2X. And so forth. I mean, are you guys with me? That's the same problem as that, just easier, because the bottoms are not, 2 of the bottoms are numbers. Shit. In algebra, you're like, yes, there are numbers, yay. And I understand that feeling. So what's this look like now? What can I do?
Cancel.
Why?
Is it all the same?
No.
Is it equal sign?
Good, because it's an equal sign. So I can multiply both sides by 6x. Bam, 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 bam. Some of you guys are like, it can't be right, Jeff. It's not hard enough. It's not algebra. Algebra's hard. No. So what do I get?
5x equals 6.
Yeah, 3x plus 2x equals 6. 5x equals 6. So therefore, x is 6/5.
Would you mark us down if we put 1 and 1/5?
No.
Okay.
Would you want us to write it as a word equation since it was a word problem to begin with? So it would be like 6/5 of an hour.
There you go. That's why I'm standing here waiting. 6/5 hours, right? If you don't put that, I'm going to be dork. I'm going to say 6/5 centuries. I'm almost done. All right. Maybe. So word problems, you when they give you units, you better give me units at the end. So because you got to know what the hell you just did. You get a number that's great. What's that number mean? That's almost at least as important as getting the numbers to know what the hell you just did. Does that make sense? We said it had to be less than 2 because it takes me 2 hours by myself. And sure enough, that's like you said, as a human, it makes more sense to say 1 1/5, right? 1 1/5 hours. So if you write it 1 1/5, that's beautiful. I like it. All right, how we doing? So that kind of problem, a work problem, it just is in your face. Joe can type 80 words a minute, and Sally can type 40 words a minute, and together, how long would it take? Whatever. You guys kind of with me? That's a horrible example, but that setup. So like number 102, we already said one pump can empty it in 5 days, another pump can empty it in 7 days. Together, how long? So it's got to be less than 5 because the one can do it in 5 days by itself. Sorry, no. If you get 8 as an answer, something went horribly wrong.
So then that word problem should be a fraction then.
Totally. It's got to be.
What about 106? Would that be a fraction?
No, that's the other kind. Here we go. So that's one kind of word problem that leads to fractional equations, right? Rational equations. The other kind, well, there's a lot of other kinds actually, but the main one that you're going to see is distance, rate, time problems, which of course is like your classic algebra problem. There's the Far Side joke about the guy goes to heaven and a gate says, "I'll let you in if you answer this question. The train leaves in Wyoming going 60 miles an hour east." And they're like, "Oh no, just send me to hell." I don't know why I sounded like a Borat. I don't know. No idea. Tell me now, what's the formula that relates distance? And we'll call speed, we'll call it rate. Distance, rate, and time.
R equals T over S.
Distance over rate.
And actually, I mean, if I just ask you like this, if you're going 60 miles an hour for a couple hours, how far do you go? You're going 60 miles an hour for a couple hours.
16 by
How far did you go? 60 times 2. You did speed, rate, times time. You already know that distance is rate times time. You know it. Math tries to formalize it, and that's why people hate math, but it has to be written in general so that we have a rule to use, right? So for example, if distance is rate times time, what's time equal to? How do you solve for t?
D over R.
Divide by r. So time is distance over rate, for example, right? Rate is distance over time. Yay. All right, so all that's going to come into play somehow in this problem. Let me do a problem like 106. We'll do...
The one before.
Sure, we'll do 105. Ooh, that's...
105 wasn't even on our homework.
Totally. That's why I'm going to do it.
Oh.
Because I don't like doing the homework for students. It's for you to do. So 105 is pretty much exactly like 106. Yeah, and 106 is actually a little easier than 105. It's kind of nice, believe it or not. So here's a suggestion. A lot of you guys might have seen this already. And it's nothing amazing. It's just a way to collect what you know, is to use a chart. If you don't like using a chart, you don't have to. You can actually do it a different way. But to me, a chart is just a nice way to collect what you know. And on the top, you put the formula. Distance equals rate times time. Let me stop there for a second. All right. So in this box, I'm going to put distances, if I happen to know any distances. So here I'm going to put rates, here I'm going to put times. So for number 105, for the booklets out there, it says the winner of a 6-mile bike race. So we got a 6-mile bike race. So the winner finishes 2 minutes ahead. So it's 2 minutes faster than a teammate. Good job, Jeff. And travels 2 miles an hour faster than the teammate. So the winner does that. All right. So they just throw all this information at me. So the chart's kind of a nice way to just stop and just start to populate it with stuff. So how many players are there in this problem?
2.
It's kind of weird. What are there? The winner and the teammate. Oh, poor little loser dude. Second place, and he's like, "You lost, sucker." Right? Ain't no silver medal. Sorry. So there's a winner, and then there's the other guy. Sure, we'll call it loser winner. We'll be you. We'll say there's only 2 people in this race. Where'd it go? What's the question in this problem actually asking? What's the question? Are there any bookful people
How
out
fast
there?
they went?
Yeah, find the average speed.
Yeah,
What's that?
That's the question, right? All right, let me stop there for a second. All right, so pretty much this is a word problem. I should be able to attack it, at least at the beginning, like any word problem. I have to identify what the variable is. So what am I going to let x be, or whatever variable I want to use? What's x going to represent?
Average read.
Yeah, x will be the average speed of who?
of every race.
No, because that would mean that they all went the same speed. If you make X everybody, then they all went the same speed.
Okay then.
Yeah, which one depends on the other one? The winner was 2 miles an hour faster than the loser.
So go with the loser.
Who do you have to know first?
Loser.
The loser. Just like I'm 5 degrees smaller than the largest angle, then I have to know the largest first. I mean, just like the other problems we did the other day. Who do you have to know first? I have to know the loser. So if I call the speed of the loser X, so where am I going to put X?
Right?
Yeah, the loser's speed, X. So what's the winner's speed?
X plus 2.
X plus 2. Why does that make physical sense? He better be going faster if he won.
Right.
Or else he went a different route, and that's not fair.
So is the time X plus 2? Also.
No.
Wait, so you're putting X plus 2 because of the miles or because of him being 2 minutes
Because
faster?
what are the rates? What did they tell me about how fast somebody was going? The winner traveled 2 mile an hour faster. So if this guy's X, this guy must be X plus 2.
Okay.
Stop there.
I would have thought that would have been like a time zoom.
Who? If they went twice as fast, it would have been double.
Oh, okay.
Yeah, but 2 mile an hour faster. If I go 80 miles an hour and you went 2 mile an hour faster, you're going 82, not 160. Right? That's really getting to LA fast.
So the T would be the same thing as that, basically?
What did you say?
The T, the time would be the same thing as
It
that?
can't be necessarily. Your time can't be the same thing as your rate necessarily. It might be just out of coincidence. Now stay with me now. What else do we know for sure in this? We know something for sure. There's no question.
6 miles.
Yeah. How far did we each go?
6 miles.
I went 6 miles,
And
and the loser went 6 miles. He didn't just go, oh man, you won. Oh, he actually finished the race, right? Like the marathoner that was 1 mile short. He said, I'm tired. Let me turn that. Sorry, it's a bad joke. I don't care. I like the joke. And some of you guys are like, that was a joke. So now watch. The beautiful thing about this chart, somebody brought me, a tutor was helping them with a problem like this, and they had 2 variables. There's no need for 2 variables here. Even though we don't know anything about the time really either, except we do know that it's 2 minutes faster, right? But that's going to be where the equation comes from. That's going to be where the equation comes from. Because what can I put here? What did it just say right there? What's the time that goes here? The time is distance divided by rate. So what do I put here? Distance divided by rate. Can you tell me what units the time is going to be in? No, not speed, but
minutes. Oh no, what is it? Is it
if the speeds are miles per hour, the time is going to come out to be hours. So what do we have to be careful about in this problem eventually? That they told me this in minutes, right? Your units have to match, don't they? Oh, Nikes. That's why I said number 105 is actually harder than 106. 106 they tell you hours, thankfully. Right? They tell you, I love this. You're all like, yes, this is the shit that algebra. No, come on.
Quick question. How did you get the 6 again?
They told me. It's a 6 mile race.
Oh.
Yeah, it's beautiful. They're almost always going to have to give me something. If they don't give me anything, then I can't make anything equal something. I can't work with it. They got to tell me something, just directly, and not this indirect little. They have to tell me something directly. What goes here?
So
6 over x. Its distance divided by its rate, or his. It's not an it or a dude. All right, and real quick, like we just said, they gave me this in minutes.
So isn't that 0.02 or something?
No. How many minutes in an hour?
60?
So that's 2 minutes out of.
60.
So it's 2 out of 60, which is 1 out of 30 hours. 1 out of 30, 1/30th of an hour. Right? 2 minutes is 1/30th of an hour. 20 minutes is how much of an hour?
1/3.
A third of an hour, right? Because 20 divided by 60 is 1/3. So 2 minutes is how much of an hour? 2 divided by 60 is 1/30th. It's 1/30th of an hour. It's a very small piece of an hour, right? So don't freak out about 1/30th. I expect 1/30th. This is a small piece. So how do I set this up? The winner went 2 minutes faster than the loser. So the winner, his time was 2 minutes faster. Now, what does that mean, faster in this case? Am I going to add to or subtract?
And we're faster to subtract.
Subtract. If I'm faster, did I take less time or more time? Less time. So this time, the winner's time, is the loser's time minus 2 minutes, which is also known as 1/30th of an hour. Oh, shit. So, why did I make my variable the speed? Because that was the question, wasn't it? Right? Anything else they tell me is going to be involved in setting up the equation. How did I just set up the equation? I used this piece of information. I don't have to make a whole new variable for time, because the time is going to depend on how fast they were going. I don't need a whole separate variable for it.
How'd you get the 1 over 30?
2 minutes is 1/30th of an hour. So what does this say? The winner's time,
Oh, okay.
the time for the winner, was 2 minutes less than the time of the loser. And does that make sense? That's why he won, because he came in 2 minutes ahead of the other guy, right?
Mm-hmm.
And now that the formula is set up, you could solve that easy, right? Hopefully. How do you solve this equation? Let go of all this other stuff, and what does he need? A 30 and an x, right? So now the solving of this should be easy. The setting up of this one was definitely hard. So 106 is sort of like this, except it doesn't have this weird little bit there. It tells you hours. It doesn't tell you minutes. So it's a little bit easier.
Did you say it needed a 30 and the x plus 2?
No, it's already got an x plus 2.
No, on the 30 it needs the x and the x
Oh,
plus 2.
the 30 needs an x
plus the x plus
and an x plus 2.
Okay, got it. All right.
This needs a 30
Yeah.
and an x plus 2. And
Would
this
it,
needs a 30x.
would it be easier to set up the 30 with the x plus 2 is 30x plus 60?
Whatever works for you, because that's true. All right. So now we're in the nice section. Now what can I do with these? Because it's an equal sign, I can kill them. Let's see what this comes out to be. So what do I get here?
180x
180x. Move that over.
equals 180x plus
Yeah, equals 180x plus 180 times 2, 360. So cool.
and then minus
And minus x times x plus 2. What's x times x plus 2?
x squared.
X squared plus 2x. So minus, let me see how I can say this. So minus x squared plus 2x, right? So the minus has got to go to both. See that minus sign? It's got to go to both.
Okay.
And now how do I solve this? So I get 180. What happens with the 180x's? Let's go ahead and get that.
They cross off each
Yeah,
other.
they kill each other. So there's 0 is equal. Subtract 180x. 360 minus x squared minus 2x. How do I solve that?
Put the x squared in parentheses, each one xx. No? Oh, it's a plus, you can.
Can you flip it around to the
Yeah, it's in the wrong order right now, right? And the freaking x squared is negative. I don't like that. So let me add x squared over. Let me add 2x over. And let me subtract 360 over. And as I move them, I can also put them in the right order. You can also divide by a negative. Whatever you got to do, it's easier to factor if the first number is positive. And now this is, I know this is a big ass number, but remember the other way to look at it. Two things that are 2 apart that make 360. 180. Give me 2 numbers that are 2 apart.
6.
16 and 14, I like it. What's 16 times 14? I don't know either. 224, I like it. Is that big enough? No. I'll get bigger.
20 and 18.
20 and 18, there you go. 20 and 18 make 360, yay! Which one's got to be negative?
20.
The 18's got to be negative, so it'd be x plus 20, x minus 18.
Why is it 20 to be, if it's 360?
Well, it's negative 360.
Oh, it's negative 2. I'm sorry, it's positive 2. I'm sorry. Okay.
So either x is
-20.
negative 20. Does that make physical sense? X represents speed,
No.
right? You can't have negative speed. You can have negative velocity, so I'll bring that in. But you can't have negative speed. Or x is 18, right? What does that mean? What does this by itself mean? What's
That's
x?
the loser.
Good. That's the loser's speed. That's why setting this up is really good, because it helps you set up the equation, and then it helps you answer the
So
question.
you plug that into the x plus 2.
Exactly. So the loser went 18 mile an hour, and the winner went 20 mile an hour. Cool. Yeah, Jeff. Yeah, make our whole test that next time. Yeah, I love that shit. I understand. But you pay attention to, I didn't do this problem before class. I did it in front of you. And I know I have a lot more practice at this kind of thing than you do. But if you pay attention to what I did to figure out how to set it up, I didn't know at first. And again, I know I've done them a lot more than you have, but still, I had to figure out, okay, what am I going to make the variable? Why did I make the variable what I did? Because that's the freaking question they asked me. So you pay attention to the question to set up what the variable is, right?
That's just the hardest part is right there, is setting that. Once you have that, it's...
Yeah, and then this one's a little bit weirder because you got to realize you only have to, once you get one empty box, you use the formula to fill it in. How did I know this is 6 over x plus 2? Because time is distance divided by rate. Once I know distance and rate, I know the time. I can write an expression for the time. So I've got an expression for the winner's time, an expression for the loser's time, and then I use the information to set up the equation. How did they relate to each other? Right? And they weren't equal to each other, obviously, because one won and the other one lost. They were off by 2 minutes, 1/30th of an hour. All right, I'm not saying that this is an easy problem at all, but pay attention to the process of how I set it up. How did I figure out what goes where? Let's try one more of those. Yeah, and then I think we'll take a break after this one. Is my phone doing all right?
It was blurry before.
It was blurry?
The other days, like...
Oh, yeah, I know. I had this there and it focused on the water bottle. Yeah. Sorry. All right. Let's. I think the other one I assigned was 110. Mm-hmm. So let's try 111.
Yeah, it's the same one.
Same problem. Yeah. So look at 111. It says a plane can travel 450 miles into the wind against the wind. And the same time that I can travel 750 miles with the wind. Alright, so if anybody's traveled East Coast, West Coast, West Coast, East Coast, you understand this phenomenon. Alright, phenomenon, because you're against the jet stream, with the jet stream, whatever. Right? So this is just me summarizing what's important that they tell me, right? Because normally there's a lot of words that are not important in the problem. They're important to understand in English, but I just want to summarize what I need for the math. If the wind speed is 50 mile an hour, where'd it go? Find the speed of the plane without wind. Alright, so this is sort of like, so if you're kayaking or something, anybody kayak? Kayakers? There you go, you know them. So if you kayak with the current, that's so nice, because then you can actually stop or just keep going. If you're kayaking against the current, it's a little bit harder. And sometimes actually you want to do that, you can just sit in place if you go white water kayaking, and just sit there in place. Anyway, sorry. Here's the thing, however fast the plane goes with no wind. Well, let's start here. What's my variable going to be? What's my variable going to represent?
X.
Sure, that's the variable. What's it going to represent?
The speed that we went into.
Speed of what?
The plane with no wind.
Good, because that's the question they asked, right?
No.
If you have no idea, look at the question they ask. That's going to tell you what to make the variable. You with me? Because that makes sense. The variable is what I don't know. The question, I don't know the answer yet, so I'm going to call it this. So x is the speed of the plane with no wind. I like it. So is it going faster or slower when it's going into the wind?
Slower.
Of course it is. All right. The plane is going, speed of the wind. So the wind speed is 50 mile an hour. There it is. That's what I forgot. For a second, I'm like, holy shit, they didn't give us some information.
So when you say into the wind, you mean like against it?
Exactly. Into the wind means against it, like the old mind thing, you know. And with the wind is pushing me along. Cool. I like it. And that's why you can go further with the wind than against the wind in the same amount of time. Maybe. So do you see, this is what you should do. This isn't just, I haven't done this problem yet. I didn't know which one I was going to do. So I'm reasoning it out in front of you. So into the wind. Let's set up a little box here. Into the wind and with the wind. Distance equals rate times time. Whereas now here, x doesn't go anywhere near. If I'm going into the wind, I'm not going x. That's how fast my plane goes with no wind. Right? If I'm going into the wind, how am I going faster or slower?
Slower.
So I'm not going x. I'm going x minus 50. So if I normally go 400 mile an hour, if I go into the wind, I'm now going effectively 350, 50 less, right? That's why if my forward, if I go 300 mile an hour and the wind is 300 mile an hour, my plane is going to be sitting in place, probably getting torn apart. So we don't want to think about it. Poor little plane, but it's certainly not going forward. Right. So. Are you guys with me on this?
So the wind speed on there, the 50 mile an hour, it just matters if you're going in the wind, it's against you if you're going with the wind.
Totally. So what's going to be here for with the wind is going to be, my plane is not just going x, now it's going x plus 50. Now understand this is a bit of an oversimplification like most math has to start off being. Are they going to gun the plane at the same speed? No, but we're going to assume that they're giving the plane the same speed. So overall, the effective speed is going to be less into the wind and more with the wind. All right, maybe. All right. So what do I put here?
This 450.
Because into the wind, I went 450. They told me that directly. No variable required because I know what it is. And of course, here goes 750. I've got one blank box each, right? So then I stop looking at this and I just start filling in with what I already know. Time is... So what do I put here?
450.
Good. Distance divided by rate. Same thing, except now it's going to be 750 divided by x plus 50. Now what piece of information have I not used yet?
The x, do you? No, you have that.
Of no wind?
No. I've used that. That's what x was. I haven't used this piece of information. Yeah. So this time has to be equal. There's your equation. What happened over here? Where the equation? It's not always time. It's just because of the way they asked me. The question was about speed. So time is what set up the equation. See how here time set up the equation. I looked at the times and said, how do they relate? Here, same time. So that time must be equal to that time. And why is this really, really nice? What am I allowed to do here? Cross multiply. That's awesome. So when I say the same time, that's really nice. That means whatever time I get here, I'm going to set it equal to the time there. Because it said the same freaking time.
So you set up the whole box and did everything on there just to have to figure out the last two from there, right? I know.
Good. I fill in 2 boxes each.
But you don't have to do anything with those now. You just have to do...
Yeah, these fed into this, which feed into the equation. So I've used all the information to get to the equation. Yeah,
Okay.
I like it. All right, sweet. And let's see. We got
With that, couldn't you just times it by a -1 to...
No, because they're both positive x's. So they're not different by a negative. If you multiply by negative, you get a negative x. And this guy has a positive x.
You're right.
If one was x minus 50, one was 50 minus x, yes.
Okay, so in the book, I didn't read what you wrote. The question was asked was what was the speed of the plane with no wind, or what was at the same time? So
No. This is the question. That's why I made that my variable.
okay.
The question was, what's the speed of the plane with no wind? That's why I let x be that.
So then, if that's the question on there, why then do you explain to me why you do the 450 over x minus 50? Why are you doing that as your problem solving? If you're figuring out, if it's asking what the speed of the plane with no wind.
So I can't use information about the speed to figure out the speed. So what I'm doing is I'm using information about the time, because I know something about the time,
Which is related
to figure out, the time is related to how fast it's going. That's why the equation is set up using time, but it's related to how fast it's going. Right? So I kind of understand your question, but that's why algebra is necessary in the world, believe it or not, is because I have pieces of a problem I don't know, but I have this general thing that I know. Well, I don't know what the time is here. I don't know what the time is here because I don't even freaking know what the speeds are. But thankfully I can make an expression for the times and then make them equal to each other.
Okay.
Now, of course, somebody out there, if I was out in the audience right now, I'd be saying, why don't you just fly the damn plane and just pay attention to how long it does? This is a great question. Again, some of the problems are a little contrived. You would hope the pilots would know how long it took them. But let's just say they hit their heads when they hit the ground, had a rough landing, and they forgot it. And so did everybody else associated with the plane. Anyway, so now you cross-multiply. If anybody notices, you could actually reduce these numbers, but we won't. Well, let's pretend like we didn't notice it. 450x plus... what would that be, Jeff? 22500 equals 750x minus 37500. Yeah. When you multiply by 50, you multiply by 100 and then divide by 2. Because multiplying by 100 is easy. Or you use a calculator. And then you subtract 450. I mean, now it's easy, right? Now it's just an equation. You subtract 450, so you get 300x. You add 37,500. So you get 60,000, I think.
X equals 200
So x equals 200.
miles per hour.
Good. Miles per hour. For what? And that's it. Thankfully, there's only one answer for this problem, right?
Which is without
Because there's only one thing. You have the speed of the plane with no wind, 200 miles an hour. So against the wind, it would be going...
750. Sorry, 400.
Damn,
450.
they're booking it.
Yeah.
Against the wind, they're going 150. With the wind, they'd be going 250. All right, I like it. Maybe.
So does the same time represent
The same
wind
would
at all?
No.
Oh.
These two situations, whatever times they end up with, would be the same.
Okay.
So what did we do? We wrote an expression for the time for this situation. We wrote an expression for the time for this situation. And like I just said, they're equal because it's at the same time. So that's the overriding idea is if I know this, I know the times are the same. If I could just get what one time is and what the other time is, I can set them equal to each other because they're the same. Now, I don't want me to make it sound like, this is easy. What's wrong with you? No, it's not easy, but I'm trying to show you what do you pay attention to? Where do you start? Where did I start this problem? Actually, I got to summarize shit for myself, right? Always a good idea. But where did I start? Well, what's the freaking question? That's what's going to tell me my variable, and that's pretty much what starts a word problem is. What the hell is just x?
So, actually, for me, it's not make sense because, I mean, in general, what I'm thinking, not as a math, because right now, the speed, it is 200 miles without wind. but he mentioned in the question that it is with the wind, it would be 750 without.
No.
Against the-
It would go 750
With the wind.
miles, not 750 miles an hour.
Distance.
The distance, not speed. They didn't tell me anything about the speed, right? I wasn't told anything about the speed, except for how fast the wind is going, but nothing about the plane. I didn't know what the plane was doing at all. And that's why the rates for the plane are all variable expressions, right? All right, let's take a break. Let's come back around 11. But it'll probably take me longer than that to upload this video anyway, so.